Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 5.3. And in this section they talk about the graphs of the sine and the cosine function, and they introduce some transformations that we could do to the sine and the cosine graphs. The main ones they talked about here are the amplitude, period, the phase shift, and the vertical translation. So in this example here, they say determine the amplitude, period, and the phase shift. They give us a function that says y is equal to negative cosine of x minus pi over 2. A good thing that we might want to do with this first is try to graph this on our graphing calculator. Remember to put this in radians first, just to kind of see what that looks like. That's something that we can do first here. Alright, so I'm going to go to mode, make sure that I am in radians, which I am, and then let's go ahead and go to my y equals, clear that out. We're going to do negative, make sure you use the negative sign and not the minus sign, or a lot of times you'll get an error. And we're going to do the cosine, negative 2 cosine, and that's going to be x minus pi over 2, so x minus, and I'll put that in parentheses, pi over 2, so we're going to do the second pi over 2, and double parentheses there to close that off. Alright, and let's go ahead and take a look at this and see what we got. So I'm going to do a zoom standard to start things off here. And that gives me a pretty good idea of what we're looking at. So it does look like it goes through the origin. It almost looks like a sine curve, except instead of going up starting, it looks like it goes down. But this is actually a cosine curve. And normally a sine curve would only go down to -1 and up to +1. This one looks like it goes all the way down to -2 and up to +2. And I can actually adjust my window a little bit. Let's go, let's adjust the window from the y values -3 and +3 just to get a little bit better of a picture of that. So we'll go from -3 up to +3. Let's see what that looks like. And sure enough, you can see that that certainly goes down all the way down to -2 and all the way up to +2. So like I said, it goes to the origin. So a normal cosine graph starts up here at 0, 1. So this one does not do that. This one goes farther up and farther down than a normal cosine graph, and it kind of starts different. So let's take a look at what's going on here, and let's get a definition of these three things. So the amplitude, according to our book, and that is on page 433 in our book, if you want to look up the definition for that. The amplitude for the cosine graph is just the absolute value of A. So once you have it in this form here, you just look at the absolute value of A. So this is going to be the absolute value of -2, which is equal to 2. So the amplitude of this function is 2, and that means that this curve is going up 2 and it's going down 2, which means the total height of this thing, or the total distance from the lowest point to the highest point, is 4. So that would be the amplitude of this function. Another way you could find that is if you took the lowest point, the highest point, and you took that distance, you divided by 2, you would get the amplitude here too. The next thing is the period, and we can actually calculate the period, and that is in our book on page 435. So the period, now the period is defined as the horizontal distance before the function starts repeating itself. So if And this is remember, this is a wave. So if we start here and we come across, we go down and we come up, as soon as it gets back to the starting point and starts repeating itself, so for example, from there to there, this distance from here to here would be a period. And then you notice that it will go here, back to there, and then this distance from there to there, that would be another period. So the distance it takes for this to make a complete duplicate of itself is a period. And we can find that by taking 2 pi and dividing by b. And that might be a little bit trickier to figure out what your b is. So let's go ahead and actually take this and put it into this form here. And if we did that, it would look like this. Y is equal to -2 times cosine. And really all we're doing is, man, it's kind of hard to do this with my mouse sometimes. Let me try to make that a little bit neat. Times the cosine. And that would just be a 1, right? A 1 on the outside, and then this, and then an x. And remember, we have a minus c, so we have a negative there, right? So we need a minus, and that would be a pi over 2. Pi over 2. Right, so c is actually pi over 2, and like this, right? And then close that off, and plus, and there's really nothing out there, so we have a 0 there. So our c would be pi over 2, our d would be 0, and our b is equal to 1. So this right here would just be 2 pi over 1, which is 2 pi. So this is repeating every 2 pi, and let's see if we can kind of see that on here. So it looks like it starts here, and by the time this thing starts over again, it's right here. So this, if I were to go to my trace function, this point right here should be around 2 pi or around 6.28. So let's make sure that that's what that is. So I'm going to hit trace. And let's go out there and look at my x value once I get to this point right here. And it should be, yeah. And right about there, it gets very, very close. You can see this x coordinate there. It's right before it, it's about 6.21, and right after it's about 6.36. And if I were to actually find this root here, let's go ahead and do that. So I'm going to go and do a second calculate here, and I'm going to find the 0 of that function there. So I'm going to find the 0. So a left bound is right on the left, and I'm going to do a right bound on the right of it. And no, I don't want to guess, and sure enough, the root there is right at the 6.28. So right where I thought it would be. All right. And then the last thing is the phase shift. So the phase shift is just whatever value is right here. Now notice that we have a minus sign here, so that has to match the minus sign here. So the phase shift is actually going to be a positive pi over 2 in this case. It's actually going to be a positive pi over 2. Because we have a minus sign in our formula, it's really going to be the opposite sign of whatever's here. So since it's a negative pi over 2 here, it's going to be really a positive pi over 2 for our phase shift. And phase shift is discussed in more detail on page 433 in the book. So the phase shift is talked a little bit about in example 4 as well. All right, so I hope this helps, and I'm going to go through another example going through graphing an entire sine wave next, but this should help you with some of the problems. All right, have a great week, and look forward to next time. Thanks.